Okay, so hello everyone. This is the project walkthrough, gender prediction using sound. This is a Codecademy chapter. It's virtual, it's not dedicated to a certain country. We go by Coding Squad, the name Coding Squad. My name is Negar. I'm Google Developer Student Club's mentorship management team, and I'm a machine learning engineer and Python developer since 2019 professionally. This is our agenda. I'm just going to minimize this here. Yeah. So first of all, we're going to review some stuff that we need to know from Pandas, the module Pandas. And then we're going to explore the fuzzy module, which is like a phonetic algorithm sort of a thing. And then we're going to explore what the problem statement is actually, and then we're going to go to coding. And then at the end, we're going to wrap everything up. At the end, when we're done with the coding, I'm going to send you the filled out notebook so you have the answers in case you need them. And of course, the recording will be uploaded on YouTube. So first of all, you might be like, okay, why am I, why are we reviewing Pandas? Because mainly we're going to be working with Pandas, obviously, because we're going to work on like 2 data sets. And the fuzzy module is basically what we're going to use as well. We are going to use NumPy and matplotlib as well, but since it's not very like a logical operation, I mean, we're just going to get to it, and then I'm just going to explain briefly what it's about. Okay, so Pandas. So this is how you import the module Pandas. The short form of it is PD. Pandas is a fast, powerful, and flexible, easy to use open source data analysis and manipulation tool. And it's built on top of Python. Also, it's worth noting that like inherently, Pandas is like best friends with NumPy as well, because it's dealing with Cython, which is like the C version of Python. And it's pretty fast, and their data types just match basically because they have their own data types. Which brings us to series and data frames. So series and data frames are Pandas's special data types. And basically what they are like rows and columns. A series is just a one-dimensional data set, and a data frame is, you can kind of say that it's built on like multiple series. So it's basically like an Excel for Python. I'm going to briefly just explain the things that we're going to use. You might not be like that proficient in Pandas, so that's why I'm doing this. So this is how you read a CSV data set. DF stands for data frame, and you use read CSV, which comes with Pandas. This is the address of your data set that you want to load into DF. And this is the separator or a delimiter. Basically, in your data set, in your CSV file, you're just explaining how your data has been like separated. And usually it's actually a comma. So yeah, so this is not like mandatory to state, but it's better to do so. We can actually add a column to a data frame like this. You can kind of treat it like a dictionary. Okay, so for now we have an example data set. Okay, so this is top 50 Spotify songs. Okay, so we have a couple of rows. We have track name, we have artist name, genre, beats per minute, etc. I just cut it short here. So these are columns and these are rows. So how do we like actually select these stuff? So we have 3 ways of doing so. We're going to be using 2 of them in this project. The first one is just square brackets, just like dictionaries, right? So basically this is only for columns, by the way. So if I want to select column A out of my data frame, which is called data frame, like DF, yeah, so this is how you do it. You can also use .lock with square brackets. This is this is the norm of selecting data in Pandas, basically. Let me just check. Yes. Okay. So in .lock, you can both select a row and a column. So here you're just selecting a row. So the first argument that you put into .lock is your row, and it's a row label and not in index. And then the second thing is going to be your column. So for example, if I want to access the row 4 and its column track name, I'm going to just like select a one cell, right? So this is how you do it in this here. And you can select an entire column basically by this. This is like the slicing operation in Python. You have it in lists as well. And yeah, this is actually how, like, this is enough to know. Just know that, so we can use row and column, like access rows and columns by .lock. It's not just column. And we have .ilock. It's a little bit confusing because it uses indices instead of labels. So it's not like this. This one used labels and not indices. So this is all standard stuff. We're going to be using .lock and the square brackets. We also have something called Boolean masks. So for example, so this is a very complex problem. So let's break it down, right? So we want to choose a data point that like all data points that have the pop genre. Okay, so this is how you do it. First of all, you use df.lock, which we just discussed, and then we select, so this is like a Boolean operation, right? So it says if the genre is equal to pop, so this is either true or false, right? So this would give us every single cell that has a genre pop. And we're like, okay, so not only this, but I want their beats per minute to be below 100. So you use the AND operator, Boolean operator. Like this is important because it's not AND, like in Python, you know that we just type AND, right? When we want to say AND, but this is a Boolean operation. This is a Boolean mask. So we use just the Boolean symbol and not just AND. Okay, so yeah, so this will select every single cell which has a genre pop and its beats per minute below 100. Okay, cool. Now we're like, okay, so I want whatever data that we just collected, I want to change their genre from pop to slow pop. And this is where you see the comma and then the genre, and then you're like, okay, slow pop. And pay attention to the fact that this is all happening inside of .lock. So .lock is a very powerful tool. Okay, so this was Pandas. So I think someone new just joined. So hello, we're just going through the stuff basically. So okay, so we're done with Pandas. Now let's talk about NYIIS and the fuzzy module. Okay, so first of all, what the hell is NYIIS, whatever it's called? So it's basically the New York State Identification and Intelligence System Phonetic Code. So that's the short, like that's the long version of it. And it's a phonetic algorithm. Now, what the hell is a phonetic algorithm? It's basically an algorithm for indexing of words by their pronunciation. We usually just see the string and we do calculation based on the actual string. But here we don't care about the spelling, right? We just care about the pronunciation of it. And it's worth mentioning that most phonetic algorithms were developed for English and are not very useful for indexing words in other languages. Also, phonetic algorithms necessarily take into account numerous rules and exceptions. So it's not just, okay, so this word like has these letters, so its pronunciation is like this. It uses some sort of like a distance algorithm that kind of connects the words and like predicts the phonetic based on that. it's kind of like it's a complicated algorithm, but we're not going to go very deep in it. Okay, so let's see some examples. For example, like we have Catherine. So we have this spelling, we have Katerina, which is like a variation of the same name. As you can see, all of these three have the same phonetic representation. So this is what we mean by this algorithm. And you can see Jonathan, John, Teresa, Smith with two different spellings. Okay, so and I'm just going to show you the fuzzy. Yes, exactly. And so this is the fuzzy module. If I can. Okay. So yeah, this is what it looks like. It covers these algorithms, which are all phonetic algorithms that we just discussed: sound EX, NYIIS, which is what we're going to be focusing on, and double metaphone. You can check the documentation for more. It's kind of complicated, actually. And it's, again, with Python. So same as NumPy and Pandas, which is interesting. There's like a lot of examples here in case you're interested. Alrighty. So now we know everything that we are supposed to be knowing. So let's talk about our project. If I can exit my full screen so I can. Yes, thank you for sharing. I forgot to do that. Okay, let's talk about the project. Oh, and it's worth mentioning that this is solely Datacamp's premium project. I didn't do anything, like I didn't contribute to it. I'll just be explaining and trying to solve it. That's fully designed by them. So what is the task? Basically, we have two data sets, right? And we want to derive statistics, like gender statistics, based on the first name that exists in these two data sets. Now, what are these two data sets, right? So we have this one, which is New York Times bestselling authors, right? We have the year, book title, author, and bestseller this year. We don't really care about the book title and the bestseller this year. We care about the year and the author, like the author full name. And the other data set is baby names, NYIIS. So the names are their phonetic representation. They're not just casual names, and this only first names, right? And we have their percentage of whether they were used for females or males. Okay, so we have these two data sets. We somehow need to connect them. Well, hint is the phonetic algorithm. So we need to get the names inside of this algorithm, this data set, right? Get the first names out of the full names, turn them into the phonetic algorithm, and then kind of connect them to this data set. And like say if they're female or male or neutral or unknown. Okay, so let's get into actually coding. I'm going to, so this is the notebook. So in case you have Jupyter installed on your computer, you can just locally access it via the GitHub repository. Else you can use Colab. Okay. And honestly, if you can't really access it, it's fine. Just come along with me and see how it goes. Okay, so the first task that we have is to basically just explore this fuzzy algorithm, fuzzy module, right? So as I said, we mainly are going to be using NYIIS, the algorithm that we just explained. So I'm importing it. In case you don't have it installed, you can install it by this. I'm just going to put it in the chat. I have installed it, so I'm just going to run it. It says already satisfied. And here we go. So I have imported it. And so the whole point of phonetic algorithms is that you don't have to rely on spelling anymore. So for example, color and color, we all know that they have two representations, like spellings, English and American. So let's just see if like NYIIS actually does anything to them. As you can see, both of them actually print color because like that's how you like kind of say it. So both of these have the same representation. Basically, that's all you need to know about that. Okay, now this task is to import the New York Times bestseller data set and kind of like just first of all analyze it and then extract the first names out of the full names. Okay, so first of all, let me just let's just see the, I mean, we already saw it a little bit before, but here I use the same thing that we discussed in the slides here. So I basically just loaded the data set inside of author df. df is data frame. And I'm just printing out the first 5 elements. This is how you do it with pandas. It's just .head. Okay, so yeah, nothing we haven't seen before. Year, author, okay, whatever. Now we want to extract like first names, right? So how do we do that? This is a string, the author that contains a string. And after the first name, we have a white space and then the last name. So that's enough for us to know how we can do this task. So first of all, we have to loop inside of author df author. So I'm accessing the column author. And then I'm just going to be like, okay, so whatever the name is, I'm going to be appending it to the first name list, okay? So I'm going to take name, right? Each name, split it. This is a built-in function for strings. And this will return a list with 2 things or 3 things, depending. The first one is always going to be the first name. So I'm just going to choose index 0. And then this way, all these first names will be inside of first name. After that, what I need to do is create a new column in author df and assign the list that I just created there. Okay, let's do that. So author df first name equal to first name list that we just created. And now, again, let's check if we did our job. And we did. So we have a new list, a new column, first name. And yeah, we have their first names. That's cool. Any questions so far? Okay, great. So let's get to the third task. So what we need to do is now we have the first names that we needed it, right, as a separate column. Now we need to iterate through them, right, and then get the names and turn them into the phonetic representation, because the second data set doesn't have like normal English, Latin stuff. So that's what we're going to do. We're going to loop through it, turn it into the NYIIS equivalent, and then create a new column inside of author df and just assign those lists to them. Okay, so for name in first name, the list that we created here. Where is it? Okay, you can also access it by the data set itself. It doesn't really matter. So what we're going to do is whatever the result is going to be, we're going to be appending it to this list. Now, what are we going to be returning? So we're going to be using the fuzzy module, this guy, and the name that we're currently at. Then we're going to create, like just like before, we're going to create a new column. we're going to be call it what we're going to call it this, and assign it to the list that we just created. Now let's check it again. And yep, here we have it. As you can see, it's kind of weird because like it's not n, but I mean that's how it just looks like. I'm not really familiar with the algorithm, to be honest, but you can check it out if you're interested. But anyway, we have the phonetic representation now here in this column. Now, we said that the whole point of this is to kind of like know which phonetic represents what gender, right? So what we're just gonna do is load our other data set, which is baby names. Let's do that. So this is exactly the same way that I loaded the other data set. And yeah, here we are. We have the baby names phonetic form here. We have the percentage they're female or percentage they're male, right? And basically what we're going to do is take, for example, if the female percentage is more, we're just going to assign it as female. So that's what we're going to do. If they're equal, we're going to assign as neutral. If the male is more, we're just going to assign it to male. Okay, so what we're going to do is to go through every single row, take every single name, and check their percentages, and just save the gender that we decide into the list gender. Okay, so how we're going to do that? So we have this great generator function called iter rows, which literally iterates through every single row in Pandas. So, and it returns two things: the index of the row and the row that exists in the data frame. So for index and for row in baby, so I named it babies df, by the way. So babies df iter rows, we're going to check the percentages. So if so let's say this, if the rows female is more than row male, just going to change this into male, we're going to be appending female into gender. The other version would be if it's the exact opposite. So male is more. So gender append male. And the other version would just be like, there's no other option but them being equal. So I'm just going to be saying else gender append neutral. Let's see if I have any errors. I don't. Okay, so now actually let's first let's look at our gender list. I'm just going to be looking at the first 10. Yeah, so we did it. So female, female, male, male, whatever. Okay, great. So now let's assign a whole new column in babies df and assign gender to it. So babies df, we've done it quite a lot of times now. Gender equal gender. And now after that, let's look at the first few rows. And we did it. So we have the gender associated with the phonetic representation of the first names. So yeah, we did it. That's great. Any questions? Is everything clear? Okay, amazing. So let's get to the 5th. Okay, great. So let's get to the 5th task. So basically we have now like a master data set of names associated with their gender, which is this guy, right? We just completed it. Now let's think about what we're trying to do. So we want the main data set that we want to work on is the author DF, right? So we want to like find every single name inside of the author DF inside of our reference, which is babies DF, right? And after we find it, we want to know the gender associated with that cell. Okay, that's great. Now the project itself has given us this function. Basically, it takes a list, it takes an element, and then it returns the index of that element inside of the list. Okay, that's great. And if it doesn't find it, it's just going to return -1. Okay, so the first thing that we need to do is loop through every single first name. The phonetic representation, which is NYIIS name column. And we want to append the gender of each author to this list, which is author gender. Okay, so let's just start. So for name, and I'm just going to copy paste of this guy. So how do they find the index of it? Okay, so we have a function for it, right? So index locate in list. Now you must be like, okay, so I'm just gonna give it the baby's data frame, and then it's just gonna magically find it. But then the baby's data set is not a list, it's a data frame. So what do we suggest that we do here? There are hints in the presentation. Okay, so let's actually think about it and kind of discover it together. So the place that we want to be, yes, so the question is that we're trying to find the index of every single name in author DF here in this baby's DF, right? So we want to check, where's the other one? Here. So here we have the NYIIS name, right? Here. This is babies, this is author DF, and we have the babies one here, and we have the genders associated with the names here, right? Now we want to find the index of every single name here in this data set, and then kind of put the gender inside of author DF. Now we already have a function for it, but the problem is that we can't really give it a data frame or a series because this is built for a list. But lucky us, in Pandas, so the only column that we really need at the moment is the babies one, and it's this column, right? It's this one. And this is a one-dimensional data set, if you will. So only considering this column, I mean. So it's one-dimensional. Lists are kind of, I mean, they are one-dimensional. It wouldn't hurt if we convert our data from a series to a list. So what we're going to do here, so we need to give it the list of babies DF, this column. And what we're looking for the name inside of that. Okay, now we have the index. It's either going to be -1 or it's going to be something more than 0 or 0. So unless it's not -1, it means that we have found an instance, right? So if our index is not -1, whatever it is, we're just going to append it to author gender. So we're going to access baby's DF with the index we just, so we're going to be using like lock. We just discussed it in the presentation. So lock with the index, the row index, and the column gender, because we want the gender. So basically this just gets the gender of that index and appends it to author gender. Yes, that's a very good question. So what if we don't have it? So here, if we can't find an instance of the element, we just return -1. So here, this happens only if the index is not -1. But if it is, then we just append unknown, because we can't really determine the gender, right? So we just say unknown. Okay, so let's run our author gender. So let's print author gender. I'm just gonna the first 10. Oh no. What is it? Which line? All right. It's the column name. So here I need to say this. Okay. Yeah, so it really did happen. We got the associated stuff, the genders with the names that are inside author DF. So that's amazing. So let's now create a new column in author DF. We're going to be naming it author gender. Author gender. And associated with the author gender list that we just created. That's amazing. So let's just look at our author DF, the first view, to see if we actually did it. And we have, okay, that's great. Yeah, you can, I think there's a method associated with like a random seed of author DF. I don't really remember it by heart right now. We can search it. Yeah, so basically we have the data set, like our data set is not complete, if you will, because we have the name, the year, the phonetic, and the author gender. That's great. So we did all of that to derive some statistics out of this, right? So the first thing that comes to mind is, okay, so how many of the New York Times bestsellers are female or male, right? So how do we actually do that? We want to choose, yes, thank you, DF sample. Amazing. That's a great thing to know. Thank you, Lena. So what was I saying? Right, so we want to see how many people are, how many of the authors are male or female. So here, we discussed this in the presentation as well. You can look at it if you forgot. So you know that if we do something like this, that you can see here, it basically, let's run it. Let's see what happens. So I'm just gonna comment this out. Okay, so it gave me a series. So I basically said, okay, inside of author DF, just return whether author gender is female or not. Okay, so it returned false, true, false, false, false. So this is all Boolean, right? So one way of counting how many females are, authors, you can just sum it. And you get 395. So why did it work? Basically in Python, it's really cool. So true and false, true is 1, false is 0, right? So it just, when it's true or false, it automatically represents it with the Boolean representation. So that's why if you sum it, it only sums the ones, hence the trues, and you get the number of the female ones. There's another way of doing so, which is using Boolean masks. Let's run it. So I'm just counting the unknowns in this one. And it's 9. So we have 9 unknown, like unknown genders and author gender. Okay, that's great. So let's just discuss how this worked. So this is a Boolean mask, right? So we're saying just choose everything that the author equals unknown, and we're calculating the length of it. Because, I mean, let's just do it without length and see what happens. It gives us a whole table. It gives us the whole rows that the author is on the author gender is unknown. So that's that. You can use both. It really doesn't matter. And that's why when you get the length of it, you get the length of the unknown ones. Does it make sense, guys? Okay. Okay, so we have actually 3 more exercises to go. So we've done most of it. This exercise basically says, so we just, oh yeah, and let's just see the male ones as well. So female and male. And then print female and male to see which one is more. So we have 395 female authors and only 191 males. So we concluded that there are more female authors in New York Times bestsellers than males. Okay, now we want to sort of compare them yearly to see how, like, did male authors drop at some point? Did they increase? Like, how's it going? I don't think we have the genre here. I'm sure there's like a bunch of different genres. So I actually left my solution here because I knew I wouldn't have the time to write everything down and then explain it. So for the sake of time, I'm just going to explain my solution. So first of all, we just derive the unique years that exist in our data set. So how did I do it? Author DF year, so the column year, and we sorted the values because that's what the task asked us. It's from 2008 to 2017, and we only selected the unique one. So it's kind of like a set, if you will. And we want to have 3 lists. So males by year, females by year, and unknown by year. And we want to loop through every year and kind of just store all of this information inside of these lists. So I'm looping through every year. I'm using bit masks here. So I'm saying the length of the female authors, and I want to make sure that, like, for example, if I'm at year 2008, I only select the rows that are in 2008. So I did that. And I did the same thing for male and unknown. And yeah, so by the end that this for loop runs, I'm going to have the number of female, male, and unknown by year, like, yeah, by every single year from 2008 to 2017. And now I have to create a data array or a data frame out of the information that I just created. So how do I do that? So first of all, it's best, so since this is sort of like a it has 3 rows, right? And it has 2008 to 2017 columns. The columns would be the years, and the rows would be the 3 males per year, females per year, and unknown by year. So this is a whole like multi-dimensional array, right? That's why I'm using NumPy. So it's just easier for me. And actually data frames accept NumPy. So that's why I created a NumPy array here. And by the way, did I import it anywhere? I guess I didn't. So I'm just going to import it here as well. So import NumPy SNP. And finally, I created some headers. So we have names for our rows. So these are row labels. And also I put year as our column labels. So if I run it, first of all, these are the 3 lists by their own, as you can see. And here we have the columns, we have the rows. And yeah, so this is a very good way of comparing them. And finally, so this is kind of like a, this is an assumption more than a truth. But so this project kind of says, okay, so maybe the reason that we don't have the author's genders inside of our baby's DF is the reason that they were not born in the US, or they have names that are not English. So they assume that they might be foreign born, right? So let's first of all kind of have it plotted out. So okay, so what is happening here? Okay, first of all, matplotlib doesn't really have, I mean, it obviously has logic, but it's sort of just syntax. So honestly, I don't know much of it by like just out of, you know, snap of my hand, but they're like their own documentation is so good that you can find whatever you're looking for. So here I'm using the inline version of matplotlib. This makes plots appear in this notebook. And I'm plotting years. So the years would be the row, so the x-axis, and the y-axis would be the unknown by year. And you can add your title, your X label, and your Y label, hence what you can see here. So as you can see here, in 2009, like we had a lot of unknown authors. And in 2017, we had some. In 2016, we didn't have any. So we didn't have anything 2012 as well, which is interesting. And the last task is saying, okay, so now we want to plot what we calculated here. Where was it? Here, we just said, okay, so females are more than male, but how do they correlate with the year, right? So here we're kind of putting them alongside each other. So in this, first of all, we have this variable years shifted. Okay, this is, you can, I mean, I changed it from 25% to 40%. It's just how it appears in the notebook. It's not really something important, but basically we're doing this because we're like, we want to add two bars like that represent male and female. So that's why we're doing this. So for the females, we're using years shifted, and for males, we're just using years. So the bars are just males per year and females per year. The males are going to be light blue, the females are going to be pink. And we have the legend. Legend is basically like a guide to what the bars mean. And let's just run it and see what happens. So we get this. So this is why we added the 40, like this one, right? Because we wanted females to like appear on the right side of the blue plot. Yeah. So we kind of see that males came down and then went up and then down. There's not really a pattern because females are clearly more. in general, but in 2014 and 16, you can see that they are kind of, the females went down a little bit. Yeah, so this was the whole project. I hope you liked it. I attached like detailed explanation of the tasks here. Yeah, so we did it. Well done, guys. I hope you kind of learned, I hope, yeah, you learned something new and I could convey what I was trying to say to you. And you can choose our next events in our polls on our Discord. I hope you're on our Discord. If not, let me share the link. How do I access it? Okay. So here is, I can copy for the life of me. So this is the Discord. So you can choose the next event. We have another upcoming event. It's just a study session for the techniques of counting discrete mathematics. I would love to see you guys there in case you're interested. It's going to be starting from 20th of November. So I'm just gonna, in case you want to RSVP. And lastly, you will see this email appear in your emails after we are done. And it would mean the world to me if you could fill it out and share your feedback. That would be great. It's just like in 4 or 5 questions. Yeah. Yes, and I will be sending you the answers via email and of course on Discord. I'll be sharing this video. Yeah, thank you so much, guys.